Hello everyone. In this video, we will be continuing with the same numericals as we did it in our previous session, that is on the sedimentation tank design. Let us take up the numerical. Two primary settling basins are 26 meter in diameter with 2.1 meter side water depth. The same thing we have noted down here. The diameter given is 26 meter since they are given circular sedimentation tank, but they are 2 in number. Okay, and side water depth H is given as 2.1 meter. Single effluent weirs are located on the peripheries of the tank. For a water flow of 26,000 meter cube per day, they have given the water flow as 26,000 meter cube per day, but since they have given two of the tanks, this flow gets divided by 2. That is 13,000 is the flow that enters each of the tank, 13,000 meter cube per day. Next, by making use of these data which they have provided, we need to find out first one, calculate the surface area and the volume. Second one is the overflow rate, that is in meter cube per meter square day. And next is the detention time, we need to calculate it in terms of the hours. And fourth one, that is the wear loading, we need to calculate in meter cube per meter day. This is the question they have given. So in order to find out the first one, that is the area and the volume, first of all we need to calculate the detention time. So let us calculate it. So this formula previously already we have used it in one of the design, we did it on a circular sedimentation tank. We can see here detention time dt is equal to d square into 0.011 d plus 0.785 h divided by q. Here we can see all the data we have in order to substitute it into this problem. That is the data d, that is the diameter we have, h is the depth we have, and the q is the flow already we have. So now we want the detention time in terms of the hours. So if we find out the detention time, it's also useful for calculation of the area and volume, and also we will be finding the third parameter what they have asked. So in order to substitute here, see here, this is in meters plus this is in meters. So unit left out is meter here. So here it is meter square since d square is there. What is left? It is meter cube. So here unit is meter cube per day. So meter cube gets cancelled. Left out unit is per day. But we don't want it for day. So we want the answer per hour. So in order to do that, what we will be doing is Q is equal to 13,000 divided by 24. So then the unit will be converted into meter cube per hour. The same thing I am going to substitute here. So let us substitute the noun data. So the diameter value 26 square 0.011 into 26 plus 0.785 into 2.1 divided by Q value 13,000 divided by 24. So the remaining answer will be 2.41 hours. So the detention time now we have calculated in terms of the hours. The answer is 2.41 hour. Next thing we need to calculate is the amount of water that is treated during the detention time. Next thing we will be calculating is what is the quantity of water that is treated during the detention time. That will be regarded as the capacity for which we are going to design the other parameters. Here we can see they have given 13,000 meter cube per day is the water that is getting entered per day, which means the quantity of water per 24 hours is 13,000 meter cube. If for 24 hours 13,000 meter cube is there, what is the amount or quantity that can be treated, quantity of water that can be treated during the detention time? So for calculation of that, as we did it in our previous classes, so if in 13,000 is the amount that we are going to treat it in 24 hours, what is for 2.41 hours? So to do that, just we are going to cross multiply. By that we have 13,000 into 2.41 divided by 24, that is the 24 hours. So the answer we will be getting it as 1308 cubic meter or meter cube. So this is a quantity we are getting. Since this is in hours, that gets cancelled, hour gets cancelled, left out unit is cubic meter or meter cube. This one we can call it as the capacity of the tank, for which we need to go for the calculation of the area and also other parameters. So now after having the capacity, then we can easily go for capacity is nothing but the volume. Since we have data for volume and also for the depth, we can directly calculate the next parameter, that is area. Since with the previous step we have already calculated the required volume, the capacity we have written, capacity is nothing but the volume which was required. Volume we have calculated is 1308 cubic meter. This was the volume we got. Now we can calculate the surface area. Surface area is equal to volume divided by depth. So volume is 1308 meter cube divided by depth, we have it as 2.1 meter. Unit left out is meter square. Answer is supposed to be 623 meter square. The second parameter we need to calculate is the overflow rate. Overflow rate is nothing but the discharge per unit surface area. So the discharge per day we have it as 13,000 per tank, 13,000 meter cube per day. So surface area we calculated it as 623 meter. So answer is 20.87. Unit will be meters cube divided by meter square day. So this is the overflow rate that is obtained for the given tank. The third parameter already we have found it as detention time. Initially only we got it as 2.41 hours. So that is done. The last one we need to calculate is the wear loading. So the last parameter what they have asked is the wear loading. In order to calculate the wear loading, first of all let us understand what is the meaning of the wear. See, whenever we are considering a sedimentation tank like this, so rather than making the flow of the water to enter somewhere through the pipe, what they do is they provide a channel like structure at the periphery, which means if this is the circular structure, throughout the structure we are providing one channel like structure. So that one we are going to call it as a weir. So rather than getting entered through some single point, the water that is getting inside the sedimentation tank is entering the weir, and then it will be gradually entering into the sedimentation tank. So this is the idea behind providing the sedimentation tank. How we are going to load the weir, that is what we are going to calculate it now. So which will be calculated, that is discharge per length of the weir, that is in meter cube per meter day. So in such a way we are going to calculate. This will be a channel like structure. So now we are discussing about that one. So first of all, before calculating the weir loading, first of all we need to calculate length of the weir along the periphery, which means periphery of the tank. Throughout this, what is its complete length? To calculate that, we have the simple formula pi d. So pi into the diameter is 26, which is supposed to be 81.6 meter. So this is the length of the weir along the periphery of the tank. Next one we need to calculate is the weir loading per day. So to calculate that, we have discharge per day divided by length of the weir. So to calculate discharge is already given in the question as 13,000, that is in meter cube per day, and length we have it as 81.6 and 81.6 meter. So the final answer is supposed to be 159.23 meter cube divided by meter day. Here we can see the answer is 159.23 meter cube per meter day. So this is the final answer for the weir loading. The seventh numerical we are taking up is a rectangular sedimentation basin is to handle 10 million liters per day of raw water. Okay, the quantity they have given is 10 million liters per day of water. Okay, a detention basin of width to length ratio they have given it as 1/3 is proposed to trap all particles larger than 0.04 mm in size. Okay, size they have given here. Assuming a relative density of 2.65 for the particles and 20 degrees Celsius as an average temperature, compute the basin dimensions. If the depth of the tank is 3.5 meter, calculate the detention. So in this problem, they have asked you to calculate the detention time. In order to calculate the detention time, we need to have few other parameters. First, let us find out the settling velocity of the particles, so that we can use it for further calculation of the length and also the flow velocity. So by making use of the given data, so we can calculate the settling velocity. Previously in another problem, we have used a different formula for the settling velocity. In this problem, we will be taking up this one, that is Stokes' law equation. Why? Because here the temperature data is been clearly given. If temperature data is not available, then we can skip for that formula. Since here it is available, we can go for this formula. Just let us substitute all other data. 418 into G is specific gravity, that is given as 2.65 minus 1. D is for the diameter. Since it is less than 1.1 mm, we are taking it as a D square, otherwise it would be D. If it is greater than 0.11 mm, it will be taken as D. The same formula will be used in that case also. Here 0.04 square, okay, 3 into 20 plus 70 divided by 100. Okay, so for this one, answer is supposed to be 1.345 mm per second, which if converted into centimeters, 0.1435 centimeters per second. So this is the answer. We have got it for the settling velocity. Next, I will be making use of this formula, that is V divided by Vs is equal to L by H, where L is the length and H is for the depth. So already we know the data for the settling tank. Let us substitute the data, and V is the maximum flow velocity. Vs, that is, let us take it, V is equal to Vs into L by H. So Vs, we have it as 0.1435 into L by H. So this is in centimeters per second. So V is equal to 0.1435 into L by H centimeters per second. So in order to calculate the length, we know some formula. Length is equal to velocity into detention time. So now we can substitute this formula what we got for velocity, that is 0.1435 into L by H into detention time T. Here we can see this is in centimeters per second. Detention time will be in hours. To convert hours into seconds, we will be multiplying by 60 into 60, T into 60 into 60. So that what happens, this is also got converted into seconds. Second gets cancelled, and the final unit for the length will be coming in terms of the centimeters. Further we can convert it for meters. So 0.1435 L by H into 3600 T. Okay. Now, if you are dividing it by 100, the final answer will be coming in terms of the meters. Since in previous step it was in centimeters, now I am dividing it in terms of 100. So the final unit will be coming in terms of the meters. So now let us solve this step. Okay, from the previous step we got the formula as L is equal to 0.1435 into L by H into 3600 T divided by 100. Now we know L on both the sides gets cancelled, and the remaining answer is 0.164 T by H. This is what it is left. Now let us take T is equal to H. I am taking on this side 5.164. Further we need to simplify it. Let us call this as equation 1. Now they have given the quantity of the water that is entering as 10 mLT. So which means, as we always calculated, what is the amount? This is the amount of water that is treated. 10 into 10 raised to 6 liters per day is the water treated. So then if during the detention period, let us say it as T, during detention period T, amount of or quantity of the water treated, that we can calculate it as. So as we do it in a cross multiplication, 10 into 10 raised to 6 liters is the amount that we are going to treat it in 24 hours. So what is the amount that we are going to treat it in T hours. So to calculate that, what we will be doing? We will be doing as 10 into 10 raised to 6, okay, into T divided by 24. So this answer is supposed to be, this is in R, this is in R, and this is in liters. Okay, so to convert it into meter cube, further I will be dividing it by 10 raised to 3, or else in this step only you can divide it by 10 raised to 3. So this is the, finally we can write it as 10 into 10 raised to 3 into T divided by 24. This is the amount of the water that is being treated during the detention period dt. Okay, so now let us call this as, calculate the quantity of water that is treated during the detention period, which we consider nothing but as the capacity for which we need to design the tank. If this is the capacity for which we need to design the tank, then we can take breadth into length into height is equal to the capacity, which means 10 into 10 raised to 3 into T divided by 24. So let us consider L is equal to 3 times the breadth. So B into 3B into H. 3B square into H is equal to 10 into 10 raised to 3 into T divided by 24. On simplification, 3B square H 416.67 T. So let us call this as equation 3. See, from equation 1 we know some value for the T. The same thing we are going to substitute in the equation 3 now. So let us substitute the value. See, here in this step we have substituted the previous equation 1. This value is coming from the equation 1. The same thing I have substituted in the equation 3, that is H divided by 5.164. Here we can see we can cancel H and we can get some value for the B on simplification, and B value will be coming as 5.19 meter, which we can write nearly as 5.2 meter, since we know L is equal to 3 times B that we have assumed. So 3 into 5.2, which will be coming as 15.6 meter. So we got length value, and the H value we can calculate, depth or height of the tank is 3.5. So now by knowing the depth H, by having the equation 1, from the equation 1 we know T is equal to H divided by 5.164. Let us substitute the H value as 3.5 divided by 5.164. The answer that is coming is 0.68 hours, which is nearly 41 minutes. 41 minutes is the detention time that is coming in this problem.